Hello, my dear children. Today we are going to discuss about determinants of a matrix. See the concepts. First point. What is meant by determinant of a matrix? To to every square matrix, A is equal to matrix Aij of order n. We can associate a number. That number may be a real number or a complex number is called determinant of the square matrix A, where Aij is equal to ith row jth column. Okay, ith row jth column element of A. Here Aij denotes ith row jth column element of A. The determinant of a square matrix A is determined by det A or det A or delta. We can use any one of these three notations. Okay, my dear children. Now, note this point, remark this point. For every square matrix A, det A is read as determinant of A and not modulus of A. Remember this point, my dear children. It looks like modulus of A, but we read it as determinant of A. Now, second point, only square matrices have determinants. Remember this point also. You have studied different types of matrices in the first exercise. Okay, my dear children. So, only square matrices have determinants. Means square matrix of order 1, 1 by 1, a matrix of order 2 by 2, a matrix of order 3 by 3. These are said to be square matrices. Only these kinds of matrices have determinants. Okay, my dear children. Now come to the point number 2. Determinant of a square matrix of order 1. Let us find the determinant of a square matrix of order 1. Let A is equal to matrix A. What is the order of matrix? 1 by 1, because only one row is there and only one column is there. Okay, so the order of this matrix is 1. Then the determinant of this matrix A is defined be A. Whatever the element is given, that only the determinant of the matrix of order 1. Understood, my dear children? Right. Now come to the next point. Determinant of a square matrix of order 2. If a square matrix of order 2 means 2 by 2 square matrix is given. In that case, how to find the determinant? Let us consider A is equal to matrix A11, A12, A21, A22. Okay, this is the square matrix of order 2 by 2. Be a square matrix of order 2 by 2. Then the determinant of A is defined as det A is equal to, this is also another notation, det A, not modulus A. Remember this point, my dear children, is equal to delta. This also denotes determinant of the matrix is equal to det. This is not modulus. Okay, my dear children, remember this one. Determinant A1, 1, A12, A21, A22. Now we find the determinant of this matrix, value of this matrix. This symbol denotes not matrix, determinant of this square matrix. Okay, my children. To find the value of this determinant, A11 into A22, we have to take cross multiplication. Look like cross multiplication. This number into this number minus this number into this number. That means A11 into A22 minus A21 into A22. Okay, my children. Just like a cross multiplication, in between minus symbol. Understood, my dear children? How to find the determinant of a square matrix of order 2? Right. Now come to the next point. Determinant of a matrix of order 3 by 3. In our syllabus, we find the determinant of a square matrix of order 1. We find the determinant of a square matrix of order 2. And finally, we find the determinant of a square matrix of order 3 only. Okay, my dear children. Now let us take this point. Determinant of a square matrix of order 3 can be determined by expressing it in terms of second order determinants. Okay, my dear children, you have already found second order determinant. This is called second order determinants. Okay, this is known as expansion of a determinant along a row or a column. With the expansion, with the help of expansion along a row or along a column, we find the determinant of a square matrix of order 3. There are 6 ways. There are 6 ways of expanding a determinant of order 3 corresponding to each of 3 rows, namely R1, R2, R3. R1 denotes first row, R2 denotes second row, R3 denotes third row, and 3 columns, namely C1, C2, C3. C1 denotes first column, C2 denotes second column, similarly C3 denotes third column, giving the same value as shown below. Okay, my children, if you expand the determinant along any one of the rows or along any one of these columns, we get the same value. Okay, my children, consider the determinant of a square matrix A is equal to Aij of order 3 by 3. That is, det A is equal to determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is a square matrix of order 3 by 3. We are finding its determinant. This is not matrix. This symbol denotes determinant of this square matrix, not modulus and not matrix. Remember this point. First, you must remember this signs plus, minus, plus, minus, plus, minus. In this order, you have to remember plus, minus, plus. You have to remember this order. First element plus, minus, plus, minus, plus, minus, plus, minus, plus. In this order, you must remember. Okay, my dear children. Now we expand the determinant of this matrix along the first row. Okay, my dear children. Right. See here, what are the elements in the first row? A11, A12, A13. Okay, my dear children. And again, remember these symbols plus, minus, plus. Okay, my dear children. Now, first we take A11, element A11. We write outside A11. Now, this element lies in the first row and first column. So, close that first row and first column. By removing these first row and first column, what will be left here? A22, A23, A22, A22, A23, A32, A33. We get a 2 by 2 matrix. We take its determinant. Understood this part, my dear children? Now, next, what is the symbol here? Minus. So, we keep here minus. Next, second element A12. We take A12. Okay, my dear children. After taking this element, we have to close this first row and this column, second column. First row and second column. By closing this first row and second column, what elements will be left? A21, A23, A31, A33. We write its determinant here. A21, A23, A31, A33. Understood this term, my dear children? Right. Now come to the third term. Here we keep plus. I said here plus symbol. So we keep here plus. Okay. Now third element A13. We write outside. Into we close this row, first row and third column. First row, third column. By closing this first row and third column, what elements will be left? A21, A22, A31, A32. We write all these 4 elements here. We take the determinant of this 2 by 2 matrix. Okay, my children. So, we have expanded here the determinant of this matrix along R1. This is the procedure. You know how to find the determinant of this 2 by 2 square matrix. Before itself, we have found. Here also we find the determinant of this square matrix of order 2 by 2. Here also we find determinant of the square matrix of order 2 by 2. Understood? 3 terms are there. Okay, my dear children. By simplifying these 3 terms, we get the determinant of the matrix A. Similarly, if we want to expand the determinant along second row, now come to the second row. What are the elements in the second row? A21, A22, A23. Remember these three elements and remember these signs also, minus, plus, minus. So first we take minus. Okay, my dear children, minus. I wrote here minus. Next, first element in the second row, A21. What is that? A21. Now we close this row, first row, second row and first column. We close this row because this element lies in the second row and first column. We close this second row and first column. There will be left these four elements, A12, A13, A32, A33. We write all these four elements, A12, A13, A32, A33. Okay, understood my dear children this term. Now we write the second term. Before writing the second term, what is the sign here? Plus. So we keep here plus sign. Next, what is the next element, second element in the second row? A22. We write it A22. Now we close this second row and second column because this element lies in the second row and second column. So we close this second row and second column. Then what elements will be left? A11, A13, A31, A33. I wrote this A11, A13, A31, A33. We find its determinant. Okay, my children. Now come to the sign. What is the sign here? Minus. We keep here minus. And what is the last element in the second row? A23. We write A23. Now what is the step to be taken here? We have to close this row and column because this element is lying in the second row, third column. By closing this row and this column, we get A11, A12, A31, A32. We write its determinant. Okay, my children, understood these three terms. By simplifying these three terms, we get determinant of the matrix A. Understood, my children? Similarly, we can expand the determinant of the square matrix along third row. Along the first column, we get the same value in all these cases. Understood, my dear children? Right. Okay, my dear children. Now come to the exercise 4.1. Based on this previous knowledge, determinant of a matrix, determinant of a matrix of order 1, determinant of a matrix of order 2, determinant of a matrix of order 3. Okay, my dear children, these points are very important for this exercise. See, come to the question number 1. Evaluate determinant 2, 4, minus 5, minus 1. We have to find the value of this determinant. Okay, my children, this is a square matrix of order 2 by 2. How do you find the determinant of a square matrix of order 2 by 2? This diagonal elements, we multiply these two numbers minus these two numbers. Just like a cross multiplication, 2 into minus 1, we keep here minus a sign, minus 4 into minus 5 into 4. Understood these terms, my dear children? Now we simplify these terms. 2 into minus 1, what do you get? Minus 2. Minus of here we get minus 20. Minus of minus 20, what do you get here? Plus 20. So I wrote here directly plus 20. Understood this step, my dear children? Right. Now minus 2 plus 20, what will you get? 18. So this number is called determinant of the given matrix. Understood, my dear children? Right. Now come to the question number 2. Evaluate determinant, not modulus. Remember this point, my dear children. Determinant cos theta minus sin theta, cos theta. We have to find the value of the determinant of this matrix. Let us take this matrix. Determinant of the matrix. Determinant of cos theta minus sin theta, cos theta. How do you find? Just like cross multiplication, I told you clearly. So cos theta into cos theta, we write it as a first term minus this is sin theta into minus sin theta. We write it as a second term. Now we simplify these two terms. What do you get here in the first term? Cos theta into cos theta, cos square theta. Minus of minus we get here plus sin theta into sin theta. What will you get? Sin square theta. Understood this step, my dear children? Right. Now, you know in the trigonometry, there is a trigonometric identity is there. Sin square theta plus cos square theta is equal to 1. So, instead of cos square theta plus sin square theta, we can write it as 1. So this number is said to be the determinant of the given matrix. Okay, my dear children, understood? Now come to the next question. Evaluate determinant x square minus x plus 1, x minus 1, x plus 1, x plus 1. Here also we have to find the determinant of this square matrix of order 2. Understood, my dear children? Right. Now come to the solution. Determinant x square minus x plus 1, x minus 1, x plus 1, x plus 1. This is also a square matrix of order 2 by 2. So we use the cross multiplication knowledge here. This number into this number minus, we keep here minus. Remember this point, my dear children. Minus this number into this number. Okay, my dear children, understood this step, my dear children? X square minus x plus 1 into x plus 1. This is the first term. We keep minus before writing the second term. We keep minus sign here. This number into this number. That means x plus 1 into x minus 1. This is the second term. Understood this step, my dear children? Right. Now we multiply these two expressions. By multiplying these two expressions, do you know how to multiply these two expressions? X square into x, x cube. X square into 1 plus x square. Minus x into x, minus x square. Minus x into 1 minus x. Plus 1 into x, x. Plus 1 into 1 plus 1. I have multiplied these two expressions. Then we get this expression. Minus. If we multiply these two expressions, we get x square minus 1. After multiplying them by minus, we get minus x square plus 1. I wrote this step directly, my dear children. Understood this step, my dear children? Now, by simplifying this algebraic expression, we get these three terms, x cube minus x square plus 2. Understood this step, my dear children? Right. Now come to the question number 3. If A is equal to matrix 1, 2, 4, 2, then show that determinant of 2A is equal to 4 into determinant of A. We have to show this statement. Understood this step, my dear children? Not modulus of 2A. Remember this point, my dear children, in the matrices. Okay, my dear children. Now first we write given matrix A. What is the given matrix A? 1, 2, 4, 2. Now LHS what should be found? Modulus of 2A. So without finding 2A, we can't find modulus of 2A directly. So first we are finding 2A. What is meant by 2A? We have to multiply the matrix A by 2. So I wrote here 2 into matrix A, 1, 2, 4, 2. Understood this step, my dear children? This is a scalar multiplication. Okay, my dear children. So we have to multiply each and every element of this matrix by 2. 2 into 1, 2. 2 into 2, 4. 2 into 4, 8. 2 into 2, 4. Understood this step, my dear children? Right. Now we got 2A. Okay, this is one matrix. We have to find its determinant. So determinant of this 2A matrix is equal to determinant of 2, 4, 8, 4. Okay, my dear children. Now we cross multiplication. That's like a cross multiplication. 2 into 4 minus a sign. Remember this point. Keeping the minus sign. Minus 8 into 4 or 4 into 8. Understood these two terms, my dear children? Right. 2 into 4 you get 8 minus 4 into 8 you get here 32. Understood this step, my dear children? Right. 8 minus 32, what will you get? Minus 24. This number is called the determinant of the matrix 2A. Understood, my dear children? We found the value of LHS. Now we find the value of this RHS. Now then we compare them. Understood, my dear children? Right. In RHS of the given statement, 4 into det A is there. So first of all we find det A separately. So we are finding det A. Det A is equal to det 1, 2, 4, 2. Now we are finding the determinant of this matrix. So 1 into 2, I said clearly, we use the cross multiplication knowledge here. 1 into 2 minus, remember this is sign, my dear children, 2 into 4. Okay, my dear children, understood this step, my dear children? Now 1 into 2, what will you get here? 2 minus 4 into 2, what will you get here? 8. Understood this step, my dear children? Right. Now 2 minus 8, what will you get? minus 6. So this is the determinant of the matrix A. Now come to RHS part. What is RHS? 4 into mod A. That is equal to 4 into, what is the modulus of, what is the determinant of A? Minus 6. 4 into minus 6. That is equal to minus 24. Understood, my children? Now by comparing LHS part and RHS part, they are equal. Hence the given statement is proved. Understood, my children? Right. Now come to the question number 4. If A is equal to matrix 1 0 1 0 1 2 0 0 4. If you observe this matrix, it is a matrix of order 3 by 3. Okay, my dear children. Then show that determinant of 3A is equal to 27 determinant of A. Here also we have to prove this statement. This is a square matrix of order 3 by 3. Moreover, if you observe here, two zeros are there in the first column or two zeros in the last column. If more zeros are there in any row or any column, we expand that row only, that particular row only, to get determinant of the matrix very easier. Understood, my children? So given A is equal to matrix 1 0 1 0 1 2 0 0 4. So what is the LHS part in the given statement? Determinant of 3A. So first we find 3A. 3 into, we wrote matrix A, that is equal to scalar multiplication. 3 into 1 3, 3 into 0 0, 3 into 3, 3 into 1 3. Similarly, second row elements, 3 into 0 0, 3 into 1 3, 3 into 2 6. We wrote second row elements. Now come to third row elements, 3 into 0 0, 3 into 0 0, 3 into 4 12. Understood this step, my dear children? Right, we found matrix 3A. Now we find its determinant. So determinant of 3A is equal to determinant of 3 0 3 0 3 6 0 0 12. If you observe this part, here in the first column two zeros are there. It can be observed that the first column two zeros, two entries or two elements are 0. Thus, we expand the matrix A along the first column for the finding determinant A. So, therefore, the determinant of 3A is equal to 3 into, see here, matrix 3 into, we are expanding this determinant along the first column because two zeros are there. So we are expanding this determinant along the first column. So 3 into, close this first row and first column. What will be left here? 3 6 0 12. We write the four elements here, 3 6 0 12. Okay, my children. Now I said clearly minus, plus minus plus. I said minus sign matrix also, sign matrix. So minus 0 into, close this second row and first column. We are taking this element, means it is second row, it is in the first column. So close this for second row and first column. Then 0 3 0 12, 0 3 0 12 I wrote here. Next, what is the next element? Third element is 0. So plus, keep here plus sign, plus minus plus. So plus 0 into, 0 into, if you close this column and this row, because this element lies in the third row and first column, we are removing, we are closing this third row and first column. 0 3 3 6, I wrote 0 3 3 6. Understood all these three terms, my dear children? Right. Now we expand, we simplify. 3 into, just like cross multiplication, 3 into 12 minus 0 into 6. Understood this step, my dear children? Here 0 into any number 0. Here also 0 into any number 0. So I am not writing these two terms. I am writing only the first term. Okay, my dear children? Right. That is equal to 3 into 12. What will you get? 36 minus 0 into 6. What will you get? 0. Understood this step, my dear children? Right. That is equal to 3 into, in this brackets, what will you get? 36 minus 0, 36 only. So again, 3 into 36, what will you get? 108. Understood this step, my dear children? This implies the determinant of 3a is equal to 108. Consider this is equation 1 or this is result 1. Now let us find determinant of matrix A. Determinant of 0, 1, 0, 0, 0, 0, 1, 2, 0, 0, 4. We are finding determinant of this matrix separately. Here also if you observe, in the first column there are two zeros. So we can expand this determinant along the first column. It can be observed that in the first column two entries are 0. Thus we expand the determinant along the first column for finding det A easier calculation. Det A is your calculation. Therefore, det A is equal to 1 into, see here, matrix A. Matrix A is this one, matrix A. In this matrix, we are expanding this matrix to find the determinant along the first column. So 1 into, so I wrote here 1 into. After closing this first row and first column, what will you get? 1, 2, 0, 4. I wrote its determinant 1, 2, 0, 4. After that, what I said here? Minus 0, 0 into, here 0 into. Okay, my children. Now close this second row and first column, because this element lies in the second row and first column. Close this row and this column. What will be left? 0, 1, 0, 4. So I wrote here 0, 1, 0, 4 plus, after closing this row and this column, because this element lies in the third row and first column. What will you get? 0, 1, 1, 2. I am writing here its determinant 0, 1, 1, 2. Understood this step, my dear children? Right. Now we simplify. That is equal to 1 into 4. Okay, my dear children, minus 0 into 2. I am writing only first term, because here second term is 0, third is also 0, because 0 into any number 0, here also 0 into any number 0. Now understood this step, my dear children? Right. Now 1 into, in these brackets, what will you get? 1 into 4, 4, minus 0 into 2, what will you get? 0. Understood this step, my dear children? Right. That is equal to 1 into, in these brackets, what will you get? 4 minus 0, 4. Understood this step, my dear children? Right. That is equal to 1 into 4, 4. So this is the determinant of the matrix A, 4. Now we find 27 into determinant of the matrix A. That is equal to 27 into 4. What will you get? 108. This is the second result. So from the first result and second result, what can you say? Determinant of 3a is equal to 27 into determinant of a. Hence the given statement is proved. Understood, my dear children? Right. Now come to the question number 5. Okay, my dear children. See, evaluate determinant 3 minus 4, 5, 1, 1 minus 2, 2, 3, 1. Can you find the determinant of this matrix, my dear children? This is a square matrix of order 3 by 3. So let A is equal to, let us consider this matrix is A. A is equal to 3 minus 4, 5, 1, 1 minus 2, 2, 3, 1. Now we are finding its determinant. Determinant A is equal to det 3 minus 4, 5, 1 minus 2, 2, 3, 1. Understood these steps, my dear children? Right. Now we are expanding the determinant along R1. By expanding the determinant along R1, we get, see the matrix here, we are expanding this determinant along R1, along the first row. What are the elements in the first row? 3 minus 4, 5. What are the signs here? Plus, minus, plus. I said sign matrix also. You should remember sign matrix. That is called sign matrix. Plus, minus, plus, minus, plus, minus. Okay, my children. Remember that matrix. So 3 into, I wrote here 3 into. If you close this row under this column, what will you get? 1 minus 2, 3, 1. I wrote here 1 minus 2, 3, 1. After that, minus a sign. Remember that one, my dear children. What is the second element? Minus 4. We write here minus 4 into. By closing this row and this column, what will you get? 1 minus 2, 2, 1. I wrote 1 minus 2, 2, 1. Okay, my dear children. Next, plus a sign. Remember this order of signs. 5 into. 5 into. By closing this row and this column, what will you get? 1, 1, 2, 3. So 1, 1, 2, 3. Understood this step, my dear children? Understood how to write these three terms, my dear children? Right. Now let us go to the next step. 3 into. Just like cross multiplication. 1 into 1 minus 3 into minus 2. Okay, my dear children, understood this term, my dear children? Minus into minus, we get plus 4 into 1 into 1 minus 2 into minus 2. Understood this term, my dear children? Plus 5 into 1 into 3 minus 2 into 1. Understood these three terms, my dear children? Right. That is equal to 3 into, in these brackets, what will you get? 1 into 1. What will you get? 1. 3 into minus 2, we get minus 6. Already minus is there. So minus into minus plus. So you get here plus 6. Okay, my dear children. Plus 4 into 1 into 1. What will you get? 1. Here minus into minus plus 2 into 2, 4. Okay, my dear children. Plus 5 into 1 into 3. What will you get? 3. Minus 2 into 1. What will you get? 2. Understood this step, my dear children? Right. That is equal to 3 into 1 plus 6. What will you get? 7. Plus 4 into 1 plus 4. What will you get? 5. Plus 5 into 3 minus 2. What will you get here? 1. Understood this step, my dear children? Right. Again, 3 into 7. What will you get? 21. 4 into 5. What will you get here? 20. Plus 5 into 1. We get plus 5. Again, by simplifying these three terms, what will you get here? 46. This is the determinant of the given matrix. Understood, my dear children? Right. Now come to the question number 7. There are different parts that are there. The first part of this question, find the value of x if determinant 2, 4, 5, 1 is equal to det 2x 4, 2x 4, 6x. If these two determinants are equal, we had to find the value of x. Understood this question, my dear children? Right. So let us write this given equation. Given that 2, 4, 5, 1 is equal to that 2x, 4, 6x. You know this is a second order matrix. This is also a matrix of order 2. So 2 into 1 minus 5 into 4. Understood these two terms, my dear children? Right. That is equal to 2x into x minus 6 into 4. Just like cross multiplication by keeping in between minus. Okay, my dear children? Right. And then what will you get here? 2 into 1, 2 minus 5 into 4. What will you get? 20 is equal to 2x into x. What will you get here? 2x square minus 6 into 4. What will you get? 24. Understood this step, my dear children? Right. This implies 2 minus 20. What will you get here? Minus 18. That is equal to 2x square minus 24. Understood this step, my dear children? Right. This implies by rearranging these three terms, we get this equation. 2x square is equal to 24 minus 18. Understood this step, my dear children? Right. This implies 2x square is equal to, what will you get? 24 minus 18, 6. Isn't it or not? Right. This implies now we are sending this 2 to RHS. Then it becomes by 2. So x square is equal to 6 by 2. Understood this step, my dear children? Right. This implies x square is equal to 6 by 2. What will you get here? 3. Understood this step, my dear children? Right. This implies x is equal to plus or minus square root of 3. Understood this step, my dear children? Right.